Hello everyone, welcome to Max Learning Fun. Today we are going to see chapter 5 Arithmetic Progressions. Class 10's chapter 5 Arithmetic Progression, which is quite interesting to learn. Yes, we are going to see the introduction of 5.1, exercise 5.1. There is general form of AP. So the first topic is general form of AP. Yes, can we? Yes, this is the general form of AP, the general term of AP, the nth term of AP. A general term of AP is like a term 1, term 2, term 3. That is like A1, A2, A3, like AN, the nth term. So nth term can be represented as AN equals A plus N minus 1 into D. How can we express it? A plus N into 1. So see here. So the first term we saw, A is the first term. How? In place of N put A and C. A1 equals A plus 1 minus 1 into D. A plus 0D. Understood why A first term? Yes. So I am substituting the N with 2. What do I get? A plus 1D. Second term. Next. Third term. So A plus 2D. Understood why the nth term general form is given like this? Yes. So let's go to the chapter's examples. So let's see what is a common difference. What is common difference? Yes. So we saw the terms of an AP are like A, A2, A1, A2, A3. Yes, A4, and this goes on till AN. In maths you would see these 3 dots. Maximum you should not cross 4 or 5, maximum 3. This 3 mentions that these follow a similar rule. These follow a same rule and this continues. So these 3 dots stands for that. So common difference. So if you subtract 2 terms of an AP, you will get a number. Then not any 2. If you subtract any 2 consecutive terms of an AP, you will get a number. Same like if you cancel any 2 number, you will get a same number. This number is known as common difference. This D is known as common difference. If a sequence, see this is a AP, this is arithmetic progressions. If this AP doesn't have this common difference, you should call it as sequence. This we will be learning in our grade 11, sequences and series. But here AP, arithmetic progression, means it has common difference. If there is no common difference, you should call it as sequence, because sequence follows a rule. It doesn't have common difference, it follows rule, a simple rule. Example for sequences: 1, 3, 6, 10. Here too you can use 3 dots because this series follows a rule. But we can't tell this a sequence. If you put 3 dots for this, no, this is wrong, because this isn't a sequence. This is a sequence. It goes in the right way. See, 1 after a number 2, 3 after 2 numbers 6 after 3 numbers 7, 8, 9. So the number of digits increase. So this is the difference between arithmetic progression under sequence. Finite series. Finite arithmetic progressions. So what is a finite? We all know what is infinite. There is no end. There is no end for those numbers. For example, integers. Integers is a good example. Whole numbers is a good example. Yes? Yes. So the opposite of this infinity is finite. Infinite is finite. These have a full stop. These have an end. These have finite. These have a set of numbers which we can count. This is known as finite. Has only n number of terms. Let's take a finite arithmetic progression. 2, 4, 6, 8, 10. This goes on. No. 2, 4, 6, 8, 10 is a finite arithmetic progression. 3, 6, 9, 12. Can you tell this as a finite arithmetic progression? Yes, because in between it is following the rule and it ends at 30. Let's see another example. 4, 8, 12, 16. Can you tell this an arithmetic progression? Finite? No, because this doesn't have an end, right? Yes. So this is the difference between finite and infinite progressions. So in this exercise we are going to find which one are progressions and which is not a progression, arithmetic progression. So 5.1 is easy, so that a separate video will be there for 5.1. But one example I will show you from 5.1. 13th one. Root of 3, 6, 9, 12. Root of 3, 6, 9, 12. Infinite series. This goes on. So what we should do? Which one of these are APs? If they form a AP, find 3 more terms. Is this a AP? AP. What should AP have? Common difference. Right? There is only one criteria if the given sequence is AP. AP means it should have common difference. So let's check how to find common difference. A2 minus A1 should be equals to A3 minus A2 because first term follows a difference. Second term and third term can follow a difference. This may cause this as a sequence. So find it for both the terms. So what is A2? Root 6. What is A1? Root 3. What is A3? Root 9 minus root 6. Can we take root 3 as common? So we are getting root 2 minus 1. Can we take root 3 as common? Root 3 minus 1. Is this a AP? Root 3 minus root 2. Is this a AP? No, because this is a different difference. This is the biggest difference. So this is not common difference. So it is not a AP. Better to write it's a sequence. It is a sequence. So nth term of an AP. Let's consider the situation again in section 5.1. So they are doing some examples here. Okay. So there are some simple sums in exercise 5.1 in which we will be doing one sample sum from each. The exercise 5.2. Using three things you are going to do this. An equals a plus n minus 1 into d. That's all. Using this exercise 5.2 you are going to solve. So the first sample is finding A, finding first term. Finding first term, we are going to do a sample sum from our NCERT textbook. Yes? So A is something, B equals minus 3, N equals 18 and AN equals minus 5. See, easy to understand. First you should understand the question. See, n is given as 18. That means A 18. 18th term is minus 5. So substitute these things in this equation and see. A 18 equals A plus 18 minus 1, 17D. What is A 18 minus 5? Plus we are going to find A. What is 17D? 17 into minus 3. Bring this to the LHS. So we will be getting 17 into 3 because this will become minus and this thing will turn it into plus. So plus or else we will do that step. Minus 5 equals A plus 3. 3 plus into minus minus 3 7s are 21, 51. Bring 51 to the RHS. 51 minus 5 equals A. A equals 47. 46. A equals 46. So finding A like this you should find. If any one term misses, we can find it easily. But what if two terms are not given? Let's do one sum from that. Okay, we will do one sum. How many multiples are multiples of 4 lie between 10 and 250? How many we are going to find? So how we should do this means, yes, because see, now 10 is the given first number. So divide 10 by 4. 4 2s are 10, right? 4 2s are 8. 8 minus 10 minus 8, 2. Now what you do, add this 2 with the given number, but that is 12. So 12 is the first term, okay? 12, 16 and it goes on. What is the number that is behind 250? What is the number that is behind 250? So take 250. Divided by 4. So for the first number we add. For the last number we subtract. So we are going to find which number is nearest to 250. See 4, 6 are 24. Remaining 1, put the 0. 2s are 8, 2. Subtract 2 from 250 to 48. 248 is the number, last term. Using last term, how we are going to do this? Okay, so how many multiples of 4 means you need to find the number of numbers. How many numbers are divisible means we are going to find n. We wrote a n, right? In that this n we are going to find now. Yes. Okay, see, AN equals, what is A? 12 plus, so 248 is the last term, right? Then 248 equals 12 plus, n is not given, so n minus 1 into, what is the difference? Multiples of 4 means the difference will be 4. 248, now bring this plus 12 to the RHS, which becomes 236 equals n minus 1 into 4. Now this is multiplication, right? Bring this to the LHS. 236 by 4 equals n minus 1. Divide 236 by 4. 4s are 4 5s are 20. Then what? 4 9s are 36. So what is the value of n? 60. There are 60 numbers, multiples of 4. Understood? The last concept, which is quite easy. There are two types of sum of n terms. Sum of n terms. Let's take a AP like A, A2, A3, which goes on till AN, or else which goes on, which is an infinite series, infinite AP. The sum of n term is expressed as the term which, till which term we should find by 2 into first term plus n minus 1 into common difference. This is quite difficult, but I will tell some easy method to do this. So this is first type. If a AP is of the form A1, A2, A3, the last term of that is given, AN, which is L, is given. How you should find means, yes, n is expressed as n by 2. Last term plus first term. Yes, this is how you are going to find. Actually, mostly this is hard, but but the situations will be like using this formula. I'll give you an example. Let's take an AP 2, 4, 6, 8, which goes on. Now there is no last term, right? So which formula you will be going? So we need to find sum of n terms for 20 terms. Let us take sum of 20 terms equals 20 by 2, n by 2 into what is 2? A first term 2 plus what is 20 minus 1? 19. What is the common difference? 2. 20 by 2, 10. 2 2s are 4 plus 19 into 2. 10 into 4 plus 2 9s are 18. 2 1s are 2, 38. 10 into 42. 420. I did this by, without that, I did this by the first formula. There is no last term, right? How to find easily? See, we got the AP, the sequence. Find A20. First term is given, or else you need to find 2A plus n minus 1 into D. Then you should multiply that n minus 1 into D's value. It's hard, it takes time. So find the 20th term, nth term first. What is that? A plus 19D. What is A2 plus 19 into 2? 18, 38. But that is 40, right? So substitute in that. S20 equals, what is n by 2? 20 by 2 into 40 plus 2. That's all simple, right? 10 into 42. 420. Easy. So mostly find which method is easy to use in the exams. Thank you.